Okay, um, for today's class, we're going to continue with looping and control statements, and then we cover functions in classes. Before we get into the lecture, I would like to show you some of the common mistakes or errors that you might encounter based on the lab assignments that I just created this morning. So the first common one is after you push your uh, changes to GitHub, sometimes you might see there's an error. So all these GitHub actions should be be created when you use the template. But from time to time, you might encounter some of the errors for either your documentation or maybe the docs view. Whenever you have those errors, um, you need to click inside to see what happened. Okay, if something is not a green check mark, that means something is wrong. And how do you figure it out is to click inside. So you can always go to the actions. The most common error will either come from the docs view, which basically means to test your documentation website, or the docs after you merge your pull request, and then this one, the website doesn't update. Or some of you encounter when you update the package to upload the package to PyPI. Other of those right now, because we haven't really added a lot of stuff into the package, so I don't expect you to see errors from the others. So I want to look into these three, 1, 2, 3. So these three common GitHub actions that you might see error messages. And the first one is this docs. If you right now go to your repo and then take a look, I think a couple of you, when I go to your repo, you will see a red X on your repository. That means something is wrong. And so one of the common mistakes is you push changes directly to your repository without using a pull request. If you do that directly, then whatever pre-commit, this one is not activated. If you submit your changes to a pull request, this one can help you fix those errors. So if there's any output on your notebook, or if there's any large file, anything, if you already push, this one is just going to show you there's some errors, but it cannot fix it. Make sense? So for example, right now, I can maybe show you here, or because I have those on my local computer, so it will let me know if there's any error message. So what I recommend is try not to push changes directly to your GitHub repository unless you're 100% sure that there's no going to net any errors. If you really want, you can check it locally, right? So if you make any changes, for example, right now, let me just quickly edit my repository here, maybe the other one, okay? So here, I'm going to show you what you might encounter. If I make changes, for example, to my readme.md, somewhere here, right? I can say it's hello, something like this. So if you make any changes, you will push to GitHub directly. There's certainly a typo in there. And the pre-commit, we identified it, but it's too late because you already pushed. So what you can do, you'll be pre-commit run all files on my computer. Oops, on that activate seal. And then if I run this one, usually it should be able to find it out. If it doesn't, that means sometimes you might need to run code spell. Oh, this one I did a lot of stuff. I need to ignore because those are the website that's being viewed. So in this case, if you right now push directly to GitHub, so I'm going to show you here. I can say update. README, Control Enter, and then just push. Right? So go back to here. I'm most likely, I think it's going to find out that error. Oh, it's not. That's so that means this one is not smart enough, even though there's a typo in here. It's supposed to catch the error, so it's not going to be perfect, but some of the error might be catched, some of those might not. Let me try another one. See if we can catch the error. Oh, interesting. Let me click like this. Yeah, it's still not capturing. This is acting weird. It should be. But anyway, if you push changes to GitHub directly and you see a red cross, that means some of these in here is not activated. So if you click inside, you should be able to see what kind of things showing up an error. And then if you want to fix it, come back to your local repo, read a pull request, and then make some changes. Usually that should be a better way of fixing those errors. The other one is here. The other common error that you might encounter is when you go to the GitHub Actions. I'm going to show you here. Docs Build or what any other of those. So inside there, I think some of those still have the, maybe I already deleted it. So this one also has the typo code spell. So since we already have the code spell in the pre-commit, we don't really need those inside here, inside this docs build YML. You can actually delete this one. So I recommend. Otherwise, some of you, I think at least one or two of you, because you have this one in your GitHub Actions, it's going to check the error in all the other files. And it's also going to check this pre-commit. But this one basically is instruction, not really the typo. You might see some of these in here that some of those that I put previously, but those are actually not really error. So let me show you, maybe go to the README file here. I can say, oops, calculate MAPE. Let's see if you can catch the error here. That's weird. It's not working properly today. Anyway, so if you have some of those errors in this docs build YAML file, and it's when you click inside, it shows you the error. There's some typos. So what you can do is to come to this YML here, and inside you can delete this one. So delete the discover with typo and these two lines. So basically the pre-commit is already checking the typos. All the other you don't need to. So this is one is only needed when you don't have the pre-commit. But if pre-commit already have that, you don't need this one. You don't need to check the typo twice if it's already inside. So I recommend just remove this one. And then let me see if there's no one. Also the docs YAML file here, you can also remove this one. So name, discover, typo with code spell, then remove these two lines. Make sure that you don't accidentally remove other lines, otherwise it's going to cause a problem for others. Okay. Then I press Control S. So hopefully, no more issues. Yeah, all other files don't have that one. Okay. Once you have this, I can just with a pull request. So let me do it quickly. Git checkout SB, maybe YML, and then okay, remove whole spell from YML. Control Enter, push, and then go back to the host website here. Pull request. And create a pull request. Let's see if you can catch the error. Oh, I think I know the issue because I ignore that one in here. That's why it's not being captured. So for example, right now, if I remove this one, then it's going to show you the error. You see? This is what is happening because this one is a valid, it's called mean absolute percentage error. So it's a valid name. But code spell, you're going to treat this one as typo. But if you really want to keep it, that's why you add this one in the ignore was list here, so it's not treated as a typo. Right now, this all looks fine, but if you do this one, if you remove that and maybe say update ignore this. If I try to press Control Enter, it will not allow me. It allows me, but it's going to be an error. I'm just showing you. If I come back to right now, this one here. So in the future, when you're doing the development, just look at this what pre-commit. So this one is going to show you what the potential error. So anytime if you see this one, just make sure that you pay attention. Don't just like click merge because it might give you information. So if you click inside, I'm going to show you what error. Okay, I'm 100% sure everyone going to encounter this one somehow, like this semester, sometime. So if it give you some information here, it just come back showing you, okay, post spell, blah, blah, readme.mape, and it's trying to say, okay, this is a potential typo. You're putting mean map. But in my case, I want that one is valid. That's what I want. So in that case, then you need to go back to this pre-commit YML, and you just add whatever things you want to ignore so that the code spell doesn't treat that one as a typo. So what we want to do here, it will be, okay, I'm going to add this MAPE, all lowercase, okay? Even if you're doing like uppercase, something like that, you still need to use all lowercase. So let me show you here. If I maybe change this one, right, you saw that MAP is invalid. If I change this one, let's see if it works, okay? I say change to upper case, Control Enter. Oops. Oh, right now it's actually going to correct me when I'm even before I push to my GitHub. So that means it's going to show this one is invalid, MAPE. So what you need to do here is just to come to the pre-commit, then just type MAPE, all lowercase, okay? Don't do this. I think if you use all uppercase, it's not being recognized. So just put everything as lowercase. Okay, Control S, and then commit this one, Control Enter, and then push. Go back to the recommit here. Wait until you see the green check mark, then you're ready to go. You see, it's pretty quick. So now the error has been fixed. Next time, if you submit an assignment or whatever you push to GitHub, I want to go back to the repository. If I see any like red X, that means something's wrong. You better go inside and take a look. If you don't know how to resolve it, you're welcome to just post your screenshot and then send the link to the error so that I can take a look. I can help you take a look. So what you need to do is whenever you have that, go to the actions. There might be some error somewhere. So for example, maybe build docs. Okay, this one right now is fine. So just go inside whatever you see the error message, click, and then somewhere, for example, if this is the error, click somewhere here, and then just copy this URL, paste to GitHub discussions, so that I can click the link and then go to the error message so that I can help you debug what's the problem. Okay, so these are all good right now. I think the pre-commit is much faster. Other GitHub actions might take a couple minutes to run. So make sure you wait until everything is green, then you merge into your main repository. So I'm just going to squash and merge everything. And come back to here to check, wait for maybe a minute or two, wait until everything is green. Once you are done with the changes, always come back to your local repository, okay? Git check out main, and then git pull, okay? Don't continue to work on that GitHub branch. Otherwise, you're going to mess things up because that branch has been deleted. It won't be available after you merge the pull request. So that's the common error that you may encounter. And the third one I want to mention is make sure you pay attention to this mkdocs YML. So far, we haven't really done much yet, but when we start developing the package and adding functionalities, we're going to modify this one. And some of you accidentally delete this one, probably because it caused error or something, you just delete this one. Once you delete this one, your website will never build, okay? Even if you click your URL and the website is still alive, that's because there's a GitHub branch in here on your repo. But the GitHub pages branch is no longer being updated. So no matter what you do, what you add to your package, it will not be updated. So you always be like this. It's not what you want. So go back to check your repo. If this one is not there, you have a problem. Then you need to restore the file. Otherwise, you're going to have trouble down the road when you have this. And also make sure on your home page, you should right now have this PyPI, also the version number. If it says like PyPI not found or something, that means your package is not available on PyPI. That means you didn't set up the GitHub tokens, the PyPI tokens properly. So you need to go back to rewatch the video. And this is essential. Otherwise, your package is not published. It's not working. All right, so those are the couple common errors that I saw when I read Lab 3. And make sure that you catch up and practice, post questions and discussion board, or you can see me after class or in my office. Last thing is make sure you choose a proper name for your package, okay? So you're going to use this one for the rest of the semester. Don't choose a package name called Lab 3. You don't want to create a package for every lab, okay? You should build on top of this one. And the package name should be descriptive, not like GOG 510 and then hyphen lab 3. It's not useful. And it's not, if you're working on lab 4, then the package name is called lab 3, then it sounds a little bit weird. So make sure you watch the lectures. I know some of you didn't come to class. You skip the lectures. There are a lot of important information. So make sure that you follow instructions. Rewatch the video step by step. I show you every single step that you need to do. And if you skip some of those, you're going to have trouble when you're doing the assignment. Yes? Good question. So if you don't really know something, it can be a little bit generic, but make sure you check the PyPI, search the name, see if the name has already been taken or not. If it is already taken, you cannot use it. And if you don't know what kind of things you want to add, think about some of the courses that you have taken, some GS stuff. It can be some automation, maybe GS Auto. I don't know if this, check it out. Or maybe GS Cool, GS Analytics. I don't know. It's something that's not been taken by PyPI. And also, I would like to show you, for example, if I say GeoDev, right? So this is my package name. It's okay to add a hyphen or something. Okay, Geo maybe GeoUS, for example. So it's available now. Yeah, usage. If there's something already been taken like this, you might not be able to use GeoUS. It's part of the package name. It's exactly the same. But if you add a hyphen or something, they might be cool. Okay, Geo, maybe Geo something. Not taken. It's a good name. You can try it out. Okay. So, but it's not the final one. If you change your mind, you can create a new package. Right? I showed you before. It only takes you 5 minutes. You can have a package up and running. Set up it very quickly. And but I think after next week, you definitely need to decide on your package because we're going to start adding a lot of geospatial stuff into the package. For last and this week, we just the Python basics, just the building block. So it's okay if you have not decided yet. And another alternative would be just ask ChatGPT, Gemini, right? I'm developing a geospatial package. I want to have something relevant to this and that. Recommend some name, right? And just think about in the future, you're gonna have raise your kids, right? You're gonna have baby. You need to think about the name. You need to find out what name might be suitable for your kids. And this might be like it's the same thing, same idea. Okay? Anything else? Okay, choose a good name. I'm not asking a perfect name, but not something super specific to each lab assignment. Otherwise, you're going to recreate every package for every lab. It's wasting your time. Okay, any other questions? I think previously I used a couple of those like Geo Demo. This is another one that I chose before. Geo Hey, something like that, right? It's all like some random name that I but this semester I'm just use Geo DEV. It doesn't have to be start with Geo. It can be anything. It can be something fancy. Okay, fancy GIS, for example. You see, it's not available. It's available, right? Give it a try. You need to do it quickly, okay? Other like other people watching the video might be taking that, so you do it right after class if you want this name. Okay. All right, so that's some of the troubleshooting. Again, if you run into issues, the best way to ask questions is just go to the GitHub report discussion, post your questions, and then have a screenshot or have a link or a code snippet or something, and then I should be able to help you out. And also keep in mind, anyone can help answer the questions, okay? Not just me. I'm not available 24/7, although I'm mostly available 24/7, but anyone can help answer questions. And those who actively help others, we get some extra credit at the end of the semester. And the other way is ask ChatGPT, okay? I think what we are learning in this course, there's nothing really unique. What I'm doing essentially is give you some shortcuts. Use template and use this and that so you can develop much faster, but you can ask ChatGPT to pretty much do everything for you. It's technical questions, lab assignment, all those things. But I would not recommend, okay? Think about yourself and then try to find answers yourself before you just, unless you really run into some technical questions that you cannot really find the answers online, then try to use ChatGPT. But for lab assignments, you should avoid using those large language models. Use that as a last resort. And then you can always stop by my office, post on GitHub discussion board. I really want you to participate here in the online community. So this is where I do every day. If I run into issues with a particular repository, particular package, there's nobody like I can just call and zoom in and then ask them to help me out. No, it's like you need to learn how do I describe the question. How do I ask a good question? How do I ask a question that in a way that can be reproduced by somebody else? Then it can help you out. And you cannot just ask simple question, okay, I run into the error with GitHub Actions. Please help me out. I have no idea what errors, what specific. Is there a screenshot? Is there a link? What code do you use? What things do you do, right? And you need to actually learn how to like formalize your questions. The better you formalize, and after a while, you will get used to it. And then you can really become an open source contributor, okay? Step by step, this is what I did. I run into this error on which operating system, which was Python version, what package version. Make it very clear, then other people might be able to help you out. All right, so that's about the GitHub Actions related stuff. Next, we're gonna go back to the looping and control statements. So some of you were having issues with the control statements. I wanna quickly mention here some of the things that we didn't discuss, but it's certainly something that you need to understand is for the looping, especially for the while loops. So let's look at this example here. And I want you to pay attention. Like in programming, there are different ways of doing coding. And sometimes some people can write 1 to 2 lines. Some people might need to write 4 or 5 lines or tens of lines. So the efficiency is going to be different. So for example, in this case here, you're going to maybe, let's say here, let me go back to this question here. And I'm going to show you, okay? Oh, this is a list. Okay, so this is maybe positive. Oops. Control C, Control V. Okay, whatever. So right now I give you a coordinates with a list of coordinates with 5 coordinates inside. And I ask you to print out these coordinates when you encounter a coordinate, for example, in the Western Hemisphere, you stop. So how do we do that? Just look at it like right now. Look at it. Which one is in the Western Hemisphere? Right. So this is latitude. This is longitude, right? So which one? Negative what? Negative 1 over 8. So now if you look at that, you know it's negative 1 over 8. That one is the first one, right? So I want you to print out only the, for example, positive one. And then whenever you encounter a negative one, then you stop. You don't print anymore. You just come out. So how do we do that? Easy, right? It's a list of 5, right? Okay, this one. No, it doesn't meet the requirement. This one, no. This one, this one, yes, stop. But how do we do that? I mean, using programming. Are we using the for loop? Or are we using the while loop? While loop? Can we use a for loop? Yes or no? Yes, we can certainly use a for loop. We know the exact number of coordinates in here. So how do we do that? How to write the for loop? For something in something, right? So it will be for maybe coordinate in coordinates, all right? And what else? How do you figure out whether it's a Western Hemisphere or not? If what? Can you listen to my? That's crazy. Probably because I copied those recording, but it's guessing what I'm trying to do. That's scary. So coordinate less than 1, then what do we do? You stop. Less than 1, I don't want it, right? So in looping, there's 2 keywords. One is called break. The other one is called continue. Break means I'm done. I'm just exit. So in this case here, you can just say break, okay? And then else, right? You print out the coordinates. Make sense? On this one? Oops. Oh no. On this one. Well, oh yeah, you need 3 of those. So let me maybe just change the different numbers so they be different. All right, so run this one again, right? It's print out 3 times. So this is how we can use while loop. You can certainly also use the continue. That means, for example, if I have, look at this. If I'm asking you to print out all the coordinates in the eastern hemisphere, that means you need the longitude to be positive, right? So we have how many positive here? This list. How many? 4, right? 1, 2, 3, 4. But if you're using this way, it's going to skip because it's going to stop here. It's going to use the break. If you have some other things after that you want to use, then you use the continue. Continue means you ignore, and then you will go to the next one. You go back. Oh, so I can use the continue. Okay. Take a look at this. Oops. Run this again. Run this again. Okay. So we print out 4 of those. So either it's break or continue. So this is very important if in your conditional statements, right? So if you meet the criteria, you can decide what you want to do. So this is using a for loop. Can we do that using the while loop? So I want you to print out whenever you find a coordinate in the Western Hemisphere, I want you to stop. So how do we do that? It is very much similar to the for loops. So let me show you here. What you need to do will be very simple. While, what's the condition? While what? This might be a little bit tricky. You might, yeah, while true. True means it's always going to be executed, right? And then you have a stop condition here. So if the coordinate is this one, blah, blah, less than 1, then you break, okay? Don't use the continue because it's going to run forever, right? So while true means if the coordinates, while true, you also need to have, say, yeah, Yeah, coordinates dot pop 0. That's good. Yeah, it's pretty smart. So that means I'm going through the list. First time it's going to give me this one because you pop out. Okay, to pop up the first one, the last one. I see to pop up the last one. It's going to count from the last one to the first one. So I'm going to take the next one, and then going to go get this one. So if this less than the second number is less than 0, it's going to stop. So right now, if you look at this, coordinates, blah, blah, less than 1, break, otherwise it's going to print out. So how many do you think will be printed out using this for loop? Oh, 3 is from the beginning, sorry. Pop, it's pop -1, then it's from the last one. So right now it's popping from the first one. If you try the last one, it's going to just the last one. So it's going to pop from the beginning of this one, but you should not use continue. So let me show you. If you use the continue, you're going to run into errors. Oops. Yeah, because it's already done. After some time, the list is going to become empty. And then if the list is empty, you cannot get the coordinates. So what you can do here, if you really want to use this one, and also you can do it like this, while not. So maybe like this, while length coordinates greater than 0. What does this mean is that if your coordinate, the list has at least 9 numbers, it's good. Because when you keep popping, at the end, it will become just no numbers in the list at all. So right now, if I run this one, or continue, PINUE, you need to run the list again because the list is being modified. Okay, so if I run this one, and then run this, you see it's going to, if you use the continue, it's going to basically continue to run the loop until you finish. Because if each time you're popping the list becomes less and less items in there. Make sense? If you really have no idea, let me add just a script here. Just say looping. So py, and you can test it here. So I'm going to copy this one, and then I'm going to also run this one here, so you understand how the program is being executed, right? So I have this. I can set a breakpoint here, and then just go run, start debugging. Python debugger, Python file. Then you should be a debugger. So right now on the left side here, you should have these coordinates, right? 5 coordinates in here. Now we are looping through the coordinates. The first time, how many coordinates in there? What's the length? 6, right? So I'm going to go to here, and then you're going to get the coordinates, right? So here is going to get the first one, and then goes through this one. Because after it's being popped, if you pay attention to here, right now the length become 5. Make sense? And you go back again, run this one, this, and this is the line that's making changes, right? Right now the length is 5. If I run this line, it's going to change to 4. So every time it's popping out, right? Just like over here, and then each time I ask one of you to go out the classroom, then it become fewer and fewer numbers in the room. Eventually, there's no students in here, then the criteria doesn't meet anymore. It's going to stop. So we continue to run this one, and right. So for this time, look at this. COORD, right? Now you have this one less than 0 because it's negative. It's going to come in here. It's going to continue. If it's continue, then it's going to skip all the conditional statements. It doesn't run in this else statement anymore. Right? So pay attention. 1. And then it's going to skip, go back. Because if it goes meet this condition, it's going to run this one. Otherwise, it's going to skip all of those until you finish it. Right? And then right now, you see we only have one element. And once you pop the last element, then the length becomes 0. Once it becomes 0, you come back to the loop. Do we still have elements in here? No. Then the loop stops. So anytime if you're not sure about like how the program is executing, especially if you have a control statement, you have looping, just use the debugging. It will help you figure it out like step by step how the programming is running through. So this is for the looping and also the break and continue. So these two are very important for doing like control, basically the flow of your programming. When do you want the flow to go to where? For example, if you get a 94 total score, you get an A or A minus. Or if you're trying to assign the scholarship, you need to be like your GPA need to be greater than 3.5, and also your household income need to be below something like. Then you have multiple conditions you need to meet. And once you find this one, okay, you're done. You can exit the program if needed. The looping, and the next one, we're going to cover functions and classes. This one is probably the most important building block for the Python package we're going to build. Everything in your package is going to be structured either as a function or as a class. So it's super important that make sure you understand how to define a function and how to define a class. You don't necessarily need to have a class in your package, but you definitely going to have some functions. Without the functions, then your package will be just writing source code without really reusable. Okay, functions allows you to write reusable code blocks. So in Python, function is defined using a keyword def. It's very simple. Def and then the name of the function. Within there, you have parentheses, and then inside the parentheses, you have this is so-called parameters or arguments, right? Here we define this one single function called add a and b. If you want your function to return something, you use the return keyword a and b, return something. And inside the function here, you can do a lot of things. You can write just one line, or you can have multiple lines. Right now, this is just a single, just one line. So if you have defined a function, this is called a function definition. And inside this is called function, the body of the function. And the last one is to return. What kind of things you want to return? If you don't have something to write yet, you can write the pass. That means this function doesn't do anything. It's just like a definition, but it doesn't return you anything. So if I run this one, will you get anything? Okay, result equal to none. That means the function doesn't return anything. So if there is not a return keyword in the function, the default result will be none. So that means it doesn't return anything. Right now, if I remove this and then uncomment. Also, everything is indented, okay? Don't do it like this. If a function has been defined, you need to have something in there. And the return keyword need to be within the function. So always use the indentation, hit the tab, and then you have indentation. Then if you run this one, okay, 5 plus 3 equal to 8, right? You can also use multiply, you can use minus, you can use whatever you want. But inside here, you can write many lines. For example, I can say print adding A and B, and then return it out. So this portion is not really something returned to the function. It's something like uh, uh, a side product. When you execute the function, you can have some print statements inside. But run this one right now, you see adding 3 and 5. But this one is only when it's executing. It's coming through here, it printed out. The last step is to return the result. So this is where the result being returned. So the number, the result will be 8. So we have two parameters, A and B. Also, you can have some default values for the parameter. If I create a function called greet somebody, and you give a name, you're going to greeting, blah, blah, and then give your name, right? So inside here, if you have something, a default values, that means you don't have to provide it if you don't want to. It's an optional parameter. So here, if I provide this one, right? If you just provide the first one, greet, just the name is going to be hello, Alice. But you can also change the greeting message, right? Hi, Bob, or something. Bye, whatever you like. So this one can be changed by, for example, BYE. Oops. When you define a function, the order of the parameters is very important. And always optional parameters need to come after required parameters. So you cannot do it like this way. Okay, don't do this. It's not allowed. If you have something optional, it need to become after something is required. So right now, this is not working, right? Even though like hello or the greetings usually at the beginning, if this is what you want, you can have another optional name here, like hello. What's the most common default name? Michael. Okay, how about this? This is fine. This you can have optional, but right now it's going to greeting the name and then okay, or Alice Michael. Oh, that means right now, if you just provide the first one, you don't specify the name, it's going to be the first one going to be greetings. And that's why you have greetings and then Michael. What you need to do here, if you really want, you'll be okay, name equal to Alice. In this case, we say, okay, hello Alice, something like that. And then you also need to switch these two. Make sense? So optional parameters comes after required parameters. And you can also have multiple required parameters. You can have multiple optional parameters. You can have as many parameters as you want. So this is how it's being defined in here. Also, you can do multiply, df multiply, return this one, and then multiply. These are pretty simple functions. And when you get into geospatial, you can have some complicated functions. Here we're using the mesh, the built-in library from Python. This one is a function called Haversine, allows you to calculate the distance between two coordinates on the Earth's surface. So latitude 1, latitude 2, longitude 2, and it's going to use the radius of the Earth and then turn into radian and then calculate the distance using this all kind of complicated functions. So inside here, this is all the function body that doing all the calculation. It can become quite complicated. After that, the most important one is to return the result. You can also print the result somewhere inside the function if you want to. After that, you can call the function something like this, okay? Latitude 1, longitude 1, latitude 2, longitude 2, and then you will calculate the distance. Or I think you need to execute this one, right? Something like this. See? So you're going to show you, okay, this is the distance between those 2 points. But this one assumes that the Earth's radius is 6,371 kilometers. For different locations, the radius might be different. So sometimes you might need to make some adjustment. So in that case, you can add that one as a parameter, something like in here. So in that way, you can customize the parameters rather than hard coding the numbers. Anytime you are defining something, make sure that anything that can be customized, you add it as a parameter rather than hard coding the number. So this is the better way because you can change the radius because for some location, if the radius is higher than this number, you can customize it. But most of the time, you can just use the default values, something like this. I think in most programming languages, you're going to encounter functions all the time. And that's basically all the building blocks that for doing for creating functionality, creating reusable code blocks for your package. And this gets even more complicated. Right now, you can pass in a list of points. For example, you have 1 point, you have another point, you have a lot of points, and you can calculate the distance of this, the consecutive, the distance between those points. Okay, this is the first point, and then you're going to calculate the distance, this point to this point, this point to this point, and this point to this point. So if this is something you want, you can calculate. For example, this is more like the segment. You have a series of points, and you want to calculate the distance between different points. This is also something you can do. So it can get quite complicated. For example, here we have 3 points, right? That means you have 2 segments, right? It's a line with 3 points. So the distance between the first 2 points and the distance between the last 2 points. You can add more points if you want to. So for example, let me go back to here. How about I do this way? I add 1 more point at the end. So how many distances you're going to print it out? 4 points. How many segments? 3. What's the distance of the last one? 0, because it's the same. So you expect to get 0. And this is how flexible it is. I don't need to change the function. You can see the function handles that pretty well. All we need is to change the input. The output will be depends on the input. So these functions have the definite number of arguments. Sometimes you might want to specify, you don't know really how many numbers or how many parameters that you are not allow the user to enter. Then you can have this called the star. And then the number of variables, that means you can enter many numbers as you want. It doesn't care. It means like similar to the while loop, right? You don't need to know how many items in there. You have a condition. So this is also super useful. They can do it like this way, right? If you're trying to create a function that allows user to calculate average, then you don't need to care about how many, right? The user can enter as many numbers as they want. Anything of inside here is going to be passing into the sum function and also the length function. So that means you can provide a list of numbers. It's going to calculate the distance. So I can add 1 more, for example, here, 10, 4, 5. It doesn't matter. If we calculate it for you, depends on how many you provide. So if you need to have a function that has a very variable number of parameters, you use the star. You can also do the positional argument. You can have like double star and then KWARGS. That's also doable. So this is what this one is about. Okay. So for example, I can provide latitude, longitude, and anything else you want to provide. And after that, it's going to provide print it out. For example, if you can give a name, give a population, give a state, these names here, they do not exist in the function definition. But if you have this star KWARGS means like keyword arguments, that means you can provide essentially anything. So right now, if I run this one, it's going to show you, okay, points at blah, blah, name equal to this, population equal to this, and you can add more, right? I can say here, country equal to USA. It doesn't matter. It's going to get everything that you provide. And this is very important because some of the functions you want to allow, you want to have flexibility that allow the user to enter any keyword arguments, and then the keyword arguments be passed into the function, and then inside the function you can do a lot of things. We're going to cover this one later when you start developing the package. But one way you can find out, I can show you some of these here quickly. For example, you go to the API documentation and then go to leaf map. Leaf map uses a lot of those keyword arguments. For example, if you try to create a map, look at the map definition in here. Right? Initialize, and then the self, and then 2 stars keyword arguments. That basically means when you are creating the map, you don't know what the user wants the map to look like, and the map is so flexible. So you can provide this keyword argument, allow the user to specify, example, I want the map height to be 600 pixels. I want the center to be around this location. I want the zoom level to be this. I want the base map to be this. I want at least layer, at least this and that, right? You never know what the user really wants. So you need to make your function that's flexible enough they can accept a lot of things. So we're going to use this one quite a lot later when we develop the package. So make sure that you practice, you understand what this one is about. This means you can provide something equal to something. So using the double star, if you only provide the star, you can only provide the input. There's no parameter name. You cannot say like state equal to something. It's invalid. For example, I cannot do like this comma and then say state equal, whoops, what? State whatever, en, it's not going to work because you only have one single star. It doesn't allow you to do that. But you can certainly do it like this. WARGS. That means you can accept any keyword arguments. That means this one is being ignored somehow. Okay. All right, so that's all for today. I will see you in the next lecture.